Good morning. Today we are starting chapter 11, that is dual nature of radiation and matter. In this, first we have to study the definition of the electron emission. Electron emission can be defined as it is the process of the emission of the free electrons is called as the electron emission. Just we are including the free electron is called as electron emission. This electron emission is divided into four types. First one, fermionic emission. Second one, photoelectric emission. Third one, field emission. And last one is secondary emission. These are the four types of electron emission. First one, we have to study about the fermionic emission. Here we are telling that it is the process of the free electron, or it is the emission of the free electrons when heat is applied. Free electron when heat is supplied or when heat is applied to it is called as the fermionic electron. In this, it depends upon the fermionic. It depends upon the nature of the substances and the temperature, how much heat is converted or how much heat is taken. It depends upon the nature of the substances and the temperature of the heat. Next, photoelectric emission. It is the process of the emission of the free electron. Process of the emission of the free electron when radiation or when incident radiation is incident on it is called as the photoelectric emission. Again, it depends upon the nature of the temperature and radiation. It depends upon the nature of the substances and how much radiation we have taken. Next, third one is electric field or field emission. Again, it is the process of emission of the free electron when strong electric field is applied to it. When strong electric field is applied to it. It depends upon the nature of the substances and the strong field. Next, last one is your secondary emission. It is the process of the free electron when bombarded with the atoms. Bombarded with atoms. Here we are considering it depends upon the nature of the substances and the atoms which we have taken. These are the four types of the emission we have to study in the electron emission. Next, we are studying about the photoelectric effect. We have to study about the photoelectric effect. The photoelectric effect was discovered by Heinrich Hertz in the year 1887. It was discovered by Heinrich Hertz in the year 1887. And next, we have to study the definition of the photoelectric effect. Now, according to the photoelectric effect, we are telling that when the radiation of the suitable frequency which is made to fall on it or the certain metals which are emitted is called as the photoelectric effect. When the radiation of the suitable frequency which is made to fall on the certain metals, falls on the certain metals or the free electrons are emitted. The free electrons are emitted is called as photoelectric effect. Now next, here just we have to give the explanation of the photoelectric effect. In the explanation, just we are considering a diagram. Now in this case we are considering when the radiation which is made to fall on the metal surface which is made to fall on the metal surface, some radiations are emitted in the terms of the free electron that we are calling as the photoelectric effect. Now in this condition we have taken E is equal to h mu. This we are calling as the photon of the energy. Let us consider some electron which is made to fall on the metal surface. Some electrons take it and the electrons are emitted outside. This we are calling as the photoelectric effect. Next we have to study the definition of the photoelectrons. In the photoelectron, when the radiation or it is the process of the we are considering it is the process when a radiation of the suitable frequency which is made to fall on the certain metals or the free electrons which are emitted, then we can call it as photoelectron. Now next we have to consider here photoelectric current. This photoelectric current is due to the it can be defined as the photoelectric current can be defined as it is the current due to the photoelectron is called as photoelectric current. Next we have to study the definition of the photosensitive substances. Now to define the photosensitive substances, it can be told that these are the substances which emit the electron when the radiation of suitable frequency falls on it. Here we are considering when the radiation of the suitable frequency falls on it is called as the photosensitive substances. Next we have to study a photoelectric work function. It can be defined as when the radiation or it is the minimum energy of the incident radiation. Here we are considering it is the minimum energy of the incident radiation. Which is made to fall on the electron is called as the photoelectric work function. Now according to the photoelectric work function we can write W is equal to h V naught, or it can be written as Hc by lambda naught, where V naught is equal to we have taken C by lambda naught. Therefore V naught means threshold frequency and this is threshold wavelength. This is the expression for the photoelectric work function. W means we are telling it as a work function. Next we have to define here threshold frequency. Here to define the threshold frequency, we are telling that it is the minimum frequency of the incident radiation, below which the photoelectric effect takes place. Below which the photoelectric effect can take place is called as the threshold frequency, and other one is your threshold wavelength. In the threshold wavelength, it is the radiation we are considering. It is the maximum wavelength of the incident radiation below which the photoelectric effect does not take place. Below which the photoelectric effect does not take place. Does not take place is called as the threshold wavelength. The relation between the electron volt and the joule we have to study here. Therefore, let us consider 1 electron volt is equal to, we have taken 1.6 into 10 raised to minus 19 coulomb into 1 volt, or it may be can also written as 1 electron volt is equal to 1.6 into 10 raised to minus 19 coulomb volt. 1 electron volt. Now let us consider here coulomb volt, we are considering here joule. 1 electron volt is equal to 1.6 into 10 raised to minus 19 coulomb volt is equal to joule. Therefore, we can convert this as V is equal to W by Q, or this can be also written as W is equal to Q into V. Q means we have taken the charge, V means it is a volt. Therefore, total SI means we are getting electron volt. This is the relation between the electron volt and the joule. Now next we are studying the Linus observation on photoelectric effect. Linus observation on the photoelectric effect. Now let us consider W is the quartz window. W is the quartz window. P is the tube or a side tube. Mu A is microammeter. H, here H is the battery. B is the volt or voltage. Now next C is the cathode. A is the emitter. Now by using this diagram we are considering when the potential difference which is made to fall on the emitter plate, we are calling it as C, and the collector A, there will be no current falls. And the potential difference is there which is made to fall on the emitter plate or the collector, there will be the no flow of the current. Now second one, we are changing that emitter plate we have taken. When we are considering the emitter plate, there we are taking the negative potential. Okay, the negative potential which is made to fall on the ultraviolet ray, there will be the current flow. When we have taken that, when the emitter plate which is made to fall on the negative, that time there will be the current flow. Next, we have to study that when the ultraviolet radiations are stopped which is made to fall on the emitter. Ultraviolet radiation which is made to fall on the emitter is stopped, then there will be no current fall in the circuit. There will be no fall of the current in the circuit. Next, if there is no current falls, no current falls, then the frequency is very much less than the threshold frequency. In this circuit, if there is no flow of the current, that is what we can tell that frequency is very much less than the threshold frequency. This is just about the Linus observation on the photoelectric effect. Now, according to the diagram we have taken here, W means we are telling that it is a quartz window, C1 and the other side tube. Next, we are considering C. C we have taken here emitter plate, and A we are calling it as the collector. And this C and A is connected to the microammeter, and this microammeter is connected to the voltage V. And again, the connection of all this is connected to the battery H. One is your negative side and other one is your positive side. This is the diagram for the Linus observation on the photoelectric effect. When the ultraviolet radiation which is made to fall on the emitter, here in this case when the ultraviolet radiation which is made to fall on the emitter, the electrons are rejected.